Hi students, Miss Slyman here, and I'm going to talk to you about the sum and difference formulas. So as you might have guessed, these are formulas for sum and differences of angles. And so we're going to look at things like this, where we've got cosine of alpha minus beta, sine of alpha minus beta. So in this example, if I look here, alpha is my bigger angle, beta is my smaller angle. So if I take all of alpha and then subtract beta, I end up here at this green line is what this image is showing. And this is useful because we know we've got our unit circle exact value ratios, but what if I wanted to find, for example, sine of 15 exactly? And that's degrees. So 15 degrees, well, that's 45 minus 30. So it'd be really useful if I could somehow use the identities that I already know. What I'm going to tell you right now for sure is that this is not, absolutely not in any way the same as sine of 45 minus sine of 30. It does not work that way. So let's explore how it does work. So we're going to start our exploration with cosine of alpha minus beta. And basically, this is walking us through a proof of the rule. So we start by noticing that QP squared, so let's just look at where they're talking about. So here's QP, and we're saying that QP squared is the same as AR squared. So let's think about why that might be. And I can think about why this might be by knowing that I've got two radii of the circle here, and I've got another two radii here. This angle here, so let's zoom in on that a little bit more. So this angle here, that's my alpha minus beta. Well, alpha minus beta is also this angle here. So I've got two different ways of representing the angle. So I've got side angle side, which makes congruent triangles. So I know QP is the same as AR, so QP squared is the same as AR squared. Using the distance formula, so we haven't talked about this a lot, this is back from your geometry days. If I want to find the distance between 2 points, well, I can do x coordinate minus x coordinate squared plus y value minus y value squared, and that's going to give me the side squared. So remember, distance formula is square root of x1 minus x2 squared plus y1 minus y2 squared. And then, of course, if I square both sides, then I get d squared, which is what we're showing here. So this is just expanding our binomial. Cos alpha squared minus 2 cos alpha cos beta plus cos squared beta. And then same thing with sine. Well, notice that if I have cos squared alpha plus sine squared alpha, that's equal to 1. Cos squared beta plus sine squared beta also equals 1. So that's going to be 1 plus 1 is my 2. Cos alpha cos beta plus, minus 2 sine alpha sine beta. I can factor out the negative 2, and I get cos alpha cos beta plus sine alpha sine beta. I can repeat the same thing for AR, because we've shown that AR and QP are the same thing. And by expanding this, I've got cos squared alpha minus 2 cos squared alpha minus beta minus 2 cos alpha minus beta plus 1. Over here, it's just the sine component. So if we look over here, the difference between my y values is just the sine alpha minus beta, whereas the difference between the x values was cos alpha beta minus 1. So using this formula again, when I square this, I just get the sine squared alpha minus beta. So again, this plus this is 1, plus 1 is 2, and then minus 2 cos alpha minus beta. So now I can set these two things equal to each other. So when I set them equal to each other, my 2's are going to cancel out. I can then divide through by -2, which makes those both 1. So I'm left with cos alpha minus beta is equal to cos alpha cos beta plus sine alpha sine beta. So this is my first rule with my sum and difference. So we say that this is a difference formula because the difference of these two angles for cosine is equal to cos alpha cos beta sine alpha sine beta. So let's go back to my example of 15 degrees. If I wanted to know the cosine of 15 degrees, well, I could say that's the same as cosine of 45 degrees minus 30 degrees, which then, according to this formula, is going to be cos 45 times cos 30 plus sine 45 times sine 30. So you should know all of these values. This is root 2 over 2. This is root 3 over 2. I'm multiplying them. This is also root 2 over 2. This is a half. So I'm going to get root 6 plus root 2 over 4. There's no further way to simplify that. That is my exact value. Building on this, I can use my even odd identities to show this. So let's think about that. We said that cosine of alpha minus beta is cosine of alpha cosine of beta plus sine alpha sine beta. Well, now if I want to make it plus, I'm going to say cosine of alpha minus negative beta. According to this rule, that's going to be cosine of alpha times cosine of negative beta plus sine of alpha times sine of negative beta. I know by my simplifying this side, I get alpha plus beta. By my even odd identities, cosine of negative beta is just going to be cosine of beta, so I get cos alpha cos beta. Sine of negative beta, though, is negative sine beta, so minus sine alpha sine beta. We often shortcut this rule and this rule into one line, and we say cosine of alpha plus minus beta is cos alpha cos beta minus plus sine alpha sine beta. So notice the signs flip. When it's plus inside, it's minus between the two terms. If it's the difference, I take the sum of those two terms. Well, there's another formula for sine of alpha plus beta, and there's a formula for tan for alpha plus beta, alpha minus beta. So we could prove each of these as well, doing something similar to above, but it's not necessary going forward. What's necessary going forward is being able to use these rules. So I'm not going to go through the proofs of these two, but if you're curious about them, I encourage you to look them up or talk to us about them in office hours.